Now we'll find that when egg is placed in distilled water, now inside the egg some solution is there and outside it is distilled water. Now osmosis will occur, semi-permeable membrane is there, water will move inside, higher solvent to, now outside more solvent is there, inside the egg less solvent is there, so water will enter the egg. So what will happen? Egg will swell. And what will happen when egg is placed in NaCl solution? Now inside the egg solution is there and outside also solution is there. And what is the direction of osmosis if two solutions are there? Lower solute to higher solute. Definitely the solution which is inside the egg is less. It means it is diluted as compared to NaCl solution. So what will happen? The egg will shrink. So these examples also explain osmosis, the phenomenon of osmosis. Okay, now osmosis is not our colligative property. Our main purpose is to discuss the next colligative property, that is osmotic pressure. Okay, now what is the meaning of osmotic pressure? Osmotic pressure is denoted by symbol pi. Now what is the meaning of osmotic pressure? Again, two compartments are there. These two compartments are separated by semi-permeable membrane. On one side pure solvent is there, on another side solution is there. Okay, and these are two weightless and frictionless pistons. Okay, now if osmosis continues, what will happen? The solvent molecules will start moving towards the solution side. Okay, now what will happen? The level of solvent side will come down and the level of solution will move up. As a result of this, now this piston will come down because solvent level is moving downwards and the piston of solution side will move up. But suppose if I apply some pressure here on the solution side on this piston, okay, so that the piston neither moves up nor moves down. Okay, I have to apply some pressure on this piston which is on the solution side so that the piston does not move at all. What will happen? Now if this piston is not rising up, this piston will not move down, and as a result of this, solvent molecules will not enter the solution side. It means what we can say, the process of osmosis is stopped. So whatever pressure we are applying here so that the process of osmosis is stopped is known as osmotic pressure. Again I am repeating, the solvent molecules are moving towards the solution side. This piston is moving down and this piston is moving up. But suppose if I apply some pressure here on this piston, solution side piston, so that it does not rise up, what will happen? If this piston is not rising up, solvent molecules cannot enter this compartment. Okay, so the process of osmosis will be stopped, and this excess pressure which must be applied on the solution side to prevent the passage of solvent into it through a semi-permeable membrane is known as osmotic pressure. Is this clear? So this is the definition of osmotic pressure and it is denoted by a symbol pi. Now this osmotic pressure is a colligative property. And what is the meaning of colligative property? Which depends upon the number of moles. And experimentally they conducted several experiments and they found that greater is the concentration of the solution, more is the osmotic pressure we have to apply. Okay, so pi is directly proportional to C. It depends upon the molar. This C is the molar concentration. Okay, in the last two colligative properties we used molality, but here we are using molarity. Okay, number of moles per volume. Is this clear? So greater is the molar concentration of the solution, more pressure, that is more osmotic pressure we have to apply here so as to stop osmosis. Is this clear? Now if we remove the proportionality sign to constants, that is R and T. R, you know, this is universal gas constant, and T is my absolute temperature, that is temperature in Kelvin. Is this clear? So this is my last colligative property, osmotic pressure. Now again the next determination of molar mass from osmotic pressure. So pi is equal to CRT, because we have to solve numericals on this. Concentration is molarity now, number of moles of solute NB upon V, and this volume should be in liters. Okay, now expand this formula, NB upon V into R into T. Okay, now what is NB? Given mass upon molar mass. R is universal gas constant, T is temperature, and this volume should be in liters. So this is the formula for calculating pi, and from this formula we can calculate molar mass for molar mass of unknown solute.